Hi, this is Hudson Corcoran, and this is my determining of who killed Professor Files. So, we know from what the situation has given us that we can use Newton's law of cooling, which is in the given, and we know that the temperature at which he was found, that temperature which time elapsed was 75 degrees Fahrenheit. The temperature of the room was 70 degrees, and the temperature not, which is the temperature that the students found him in, was 80 degrees Fahrenheit. The time elapsed was 30 minutes from 7:30 to 8, and then we're solving for the decaying coefficient. So we substitute in the variables for 75 is equal to 70 plus parentheses 80 minus 70 close parentheses e to the k30. 5 is equal to 10 to the the k30, and then we're also able to say 5 over 10, or 1/2, is equal to e to the k30. Take the natural log of both sides, you're able to eliminate e from the equation and bring down k30 as factors. So then we simplify ln 1/2 to ln1 minus ln2 is equal to 30k. Divide by 30. You know ln1 over ln2 divided by 30 is equal to k. So k is approximately negative 0.693147 over 30, or k is approximately negative 0.023105, which is appropriate because the decaying factor should be negative. K should be less than 0 in Newton's law of cooling. Moving on to the next part of the problem, you have it to where we're trying to figure out how much time has elapsed since he died. So we know that once again the amount of time, the end temperature was 80 degrees Fahrenheit from when the students found him. Temperature of the room is 70 degrees Fahrenheit. And we assume that the temperature initially was 98 degrees Fahrenheit because that's the average human body temperature. And so obviously when he died, he was at the average and then slowly cooled down before he was found. And then we know that k is equal to ln 1/2 over 30, and that is it in its most absolute form, and we're solving for time. So we know that we can then substitute in the equation. 80 is equal to 70 plus 98, open parentheses 98 minus 70, close parentheses e to the kt. And then we simplify to where we get 10 over 28 is equal to e to the kt. And then natural log of 10 over 28, sorry, I forgot to simplify, is equal to ln e kt. And then we can take the natural log, and we can say ln e is 1, bring down kt as factors. Ln 10 minus ln 28 is equal to ln 1/2 over 30 times t, because that's what the k value was. And then we know that t is equal to ln 10 minus ln 28 over ln 1/2 divided by 30 parentheses. And so you get t is around 44 minutes, around 40 minutes, but it in hours would be around 0.7 hours, if this round to the nearest tenth of an hour. And then we could say the time of death is around 6:50 p.m. from the discovery at 7:30. Thank you for listening.